When solving inequalities, we treat them just as we would solving a multi-step equation with an equal sign. It's just that we have to take special care to treat that inequality the way it needs to be treated. Let's go ahead and start with an example of something like -5 is greater than a -3 plus x thirds. Instead of a greater than symbol, if we had an equal sign, we would all know that the first step would be to move constant terms together. So we would add 3 to both sides. So -5 plus 3 is a -2. We're going to bring down the inequality. -3 plus 3 is 0, leaving us just a positive x thirds. Now we'll multiply both sides by the denominator to kind of neutralize that fraction. And we have -3 times 2 is a -6. And 3 divided by 3 is 1. X divided by 1 is just x. So in the end, we have -6 is greater than x. When we have an inequality, though, we'd like to have the variable on the left. So I'm going to put the variable on the left, the constant term on the right, but I need to make sure that I'm careful with that inequality. Notice right now the smaller side or pointed side is at the x, so as I rewrite this, I need to keep the smaller side or pointed side at the x. So that gives us x is less than -6. Let's go ahead and graph this answer on a number line. So we'll put 0 over here, -1, -2, -3, -4, -5, -6, and so forth. So we know that our x values are smaller than -6. So we're going to shade in to the left of -6 where the values are smaller. We also know that since there's no equal sign, -6 is not part of the solution. So we're going to put an open dot at -6 so that we can see that the values are smaller than -6 and do not include -6. Let's look at another example. Let's have 2 is less than m plus 2 all over 3. Since everything on one side of my inequality is a fraction, I can start by multiplying both sides by the denominator, neutralize that fraction. 3 times 2 is 6. 3 divided by 3 is 1. And m plus 2 over 1 is just m plus 2. So now I can subtract 2 from both sides. 6 minus 2 is 4. And bring down the m. Again, we like the variable on the left, so we'll put the m on the left, the 4 on the right, and keep the relationship the same. The open side is at the m, the open side is at the m. So if we were to put this on a number line, we would see that there's not an equal sign. So at 4, we need to put an open dot. And the m values need to be greater than or bigger than 4. So we'll shade in to the right, which is the greater than or larger direction. There are a couple of things that you need to keep in mind with inequalities. The first thing that you need to watch out for is when to switch the inequality. Or when to change the sign. The only time that you need to change or flip the inequality sign is if you are multiplying or dividing by a negative number. So if I had something that looked like -6x is less than 4, and I needed to divide both sides by a -6. Since I am dividing by a negative, it flips my sign. So this would change from a less than to a greater than. -6 divided by itself is 1, leaving us 1x. 4 divided by a -6 would be a -4/6, which reduces down to a -2/3. So if we were to graph this, then we would know that our x values do not include a -2/3, but instead are all values greater than a -2/3. So you switch or change the inequality sign when you are multiplying or dividing by a negative. The other thing to remember is that if the equal sign is not included, we have an open dot. So let's do one last example so that we can make sure we're clear on everything. So let's say that we had 2 is greater than a negative p over 2 plus 4. Very first step, subtract 4 from both sides. You know what? Let's put that here. Let's start this one over so that we can actually have it look the way we'd like it to look. Okay, let's do this. So we have 2 is greater than or equal to, there we go, a negative p over 2 plus 4. So we'll start by subtracting 4 from both sides. 2 minus 4 is a -2. My sign stays the same because I was working with a -4, but I was not multiplying or dividing. So it's totally fine to subtract. Do not change the sign. Right here then, the negative p over 2 stays the same. 4 minus 4 is 0. That one's gone away. So now we're going to multiply both sides by 2. 2 times a -2 is a -4. 2 divided by 2 is 1, and 1 times a negative p is just negative p. Now, in order to get this negative gone next to the p, I'm going to divide both sides just by a negative symbol. You could think of it as dividing by a -1 if you prefer. Negative divided by a negative is a positive, so that gives us 4. Negative divided by a negative is a positive, giving us just p. But since we divided by a negative, it flips the sign. So I go from having a greater than symbol to a less than symbol. So we have 4 is less than or equal to p. So remember, we like to have the variable on the left, so we'll put the p on the left, the 4 on the right. Keeping the relationship the same, we have the open side at the p, so we'll have the open side at the p. So let's go ahead and take this statement and graph it on a number line. So we can start with 0, 1, 2, 3, 4, 5, 6, and so forth. Since there is an equal sign, we know that 4 is part of the solution, so we're going to have a solid dot at 4. And then the p-values are greater, so we're going to shade in above the 4. And the graph would look like this. So basically, I could pick any number, 4 or higher, plug it back into the original equation, and I would be left with a true statement.